Your stuff came off.
All right, everybody wrapped up? All right, everyone. Our next speaker is Keith. Keith has been looking up lately because the sky might be falling. He's going to give a short science speech on space weather. Space weather, interesting. Don't think too much about that. It was in the news lately, and now it's not. What's going on with that? Speech will be 6 to 8 minutes. Title, That Doesn't Sound Safe to Me. Please welcome Keith.
Oops. I need that. Morning, Toastmasters.
Morning.
What is pink, green, purple, and coming at you at 1.7 million miles an hour? A problem. That's what. Now, I'm going to talk a little bit about space weather. It's actually a big science field. There's Planet X might not be included in space weather, but supernovas might be, and this definitely was. It was in the news a couple days, and then it went away. Basically what I'm talking about is CME. Coronal mass ejection. Solar flare, boosh, at the Earth. Now, this might not seem like a big thing, but they had the scientists on board, and they were showing in the news, this is like this news cycle, they had all these scientists on board and explaining all this stuff. And then it went quickly to neon light show, Aurora Borealis, and get your screensaver now, because our industry of sunlight is now making you screensavers that are pretty for your Aurora Borealis. And they are actually neon lights. Hopefully I get to explain that. But what the heck is why did it just disappear out of the news so fast? Because the way Bill Nye, the science guy, said that a couple of pulses from this in a row could knock out our power grid, and that's like damage that would not be corrected for like a decade, 15 years, something like that. A power grid. No power for 15 years. We're goners. If you just think about it a second. I just thought, hey, I'll just try to throw out a little bit of science and see if I can say, we were pretty close to the sky is falling. This thing was a G5. Now, tornadoes, the EF5 is the biggest tornado. Well, this is 5. This is the biggest one of these. Geo probably something 5. Now, let's say history. How about a little history? In 1859, there's this thing called the Carrigan event. A solar flare came out and hit the Earth. Now, it wiped out the latest technology they had, which was teletype. Which is just those poles with wires going across, but it took out their teletype thing, so it was affecting that, and it caused like fires, St. Elmo's fire and Lahaina fire, and it can cause fires. And today, if it knocks out a power grid, it blows up transformers, they can definitely wipe out fires and have wipeout type fire disasters and explosions if a transformer goes. Well, what is this solar flare? What is it? It's magnetized plasma. Okay, what's that? Plasma, okay, here's the sun. Let's just look at the sun for a second. No, don't look at the sun. But here's the sun. Our daylight factory. And at night, it turns off and goes dormant. Because this is science. No. it's think of a thermonuclear bomb going off. A thermonuclear bomb. That's the biggest bomb that we have. Boom, boom, bomb going off. Now think of that going off, and then one right next to it going off, and then one right next to that going off, and one right next to that going off, all at the same time, continuously, 24/7, because the sun never sleeps, all over the surface of the sun. And it's big. That's what's going on the sun. And this stuff that goes out from the sun, aside from light, it's like the hydrogen atom. You know, the hydrogen atom, it's just one on the periodic, just one. It rips away that electron in it, rips away, it's just a little bit, it's just a little thing, the little center, and it's like a photon, but there's a whole bunch of them. Science. Now, why doesn't this just happen all the time? And why aren't we fried right now? I mean, I'm driving on the way over here, and then there's a song comes on, Beatles song, "Good day, sunshine." I'm like, I'm doing this speech, and it's "Good day, sunshine." I walk out, and my feet, and my feet hit the ground, and the sun burns my feet as they hit the ground. It says in the song lyric. I'm like, the sun burns your feet as it hit the ground. Oh, it's hot that day, huh? Well, a solar flare would burn everything off the planet, including the atmosphere, if we didn't have what's called the magnetosphere. Now, luckily for us in Earth, which is pretty dang unique, which is very bizarre, inside the center of the Earth, so you have the Earth, inside the middle, there's the core of the Earth is molten iron. It's molten rock, and it's moving around. That creates a magnetosphere, a magnetic sphere around the Earth, which holds the atmosphere on the Earth. If we didn't have the magnetosphere, we wouldn't have an atmosphere. It's just interesting. It would just blow away. And if we didn't have an atmosphere and this magnetosphere, you know what? We'd be fried by the sun like that, just from what's coming this way. It bends around and goes into the thing. So when now in the sun, solar flare, those little hot spots, those little black spots on the surface of the sun, every 11 years it cycles around these little black spots. They are magnetospheres on the sun, where that light doesn't come out because it doesn't do this little thermonuclear thing and that little magnetic stuff. It's like a spring. It's like it goes boing, and then it ejects out. And as it ejects out it can go across. I mean, the sun's only 98 million miles away. That's pretty close. I mean, sunlight it takes about 9 minutes. So 9 minutes or something, we get this, and it's all plasma. It would wipe out everything on Earth, like that. Or, since we had the magnetosphere, if it's strong enough, it goes down there, and then it starts to mess with gases in the air, like hydrogen gas, oxygen, argon, and then when the little electron goes up, and then it comes back down, it emits light. Just like in a neon sign. You put electricity, there's argon gas in the neon sign. There's something, inert gases in there, and it makes different colors, and that's where you have this Aurora Borealis. Oh, it's so nice, it's so pretty. Get your screensaver now. But that was such a distraction when they sat there and they left that, and they didn't listen to Bill Nye, the science guy. Because a few pulses, one after another, on our electric grid would take out our electric grid. And we would be sitting there twiddling our thumbs, and all our food would go rotten, and we'd be cold in the dark with candles. And I don't think you couldn't recharge anything. So I'm saying that we gotta think once in a while, because there's nothing we can do about it if it does. But we must think there's a lot of science that we can know that is just beyond how cool looking it is, and how interesting it was in this news cycle that it was just, oh, it's coming at us, and then it's, oh, look at you can see the Aurora Borealis down as far as Florida. Isn't that nice? Oh, yay. So it just struck me as, ain't that strange? It looks a lot more dangerous to me. Oh, I think I'll stop there. Thank you.
Thank you very much, Keith.
Thanks.
Always fascinating.
Do we have a moment for questions?
Oh, sure, if you want. Should we do questions?
Yes.
Yeah, we can do that. Q&A, sure. Because I kind of rushed through some stuff. Yeah.
My sister saw the Northern Lights from Washington, but what she saw with the naked eye looked like white clouds. When you would take a picture, your camera would pick up all the beautiful colors, but the eye didn't. Do you know why that is?
Not particularly. I mean, my guess is that cameras they have a much more greater range of the data that they can absorb, that they can see, in a sense, the lights that we can't see, like the different greens. Because magnetic radiation is light. Light is one. There's visible light. There's infrared we can't see. There's ultraviolet we can't see. But there's cameras that can pick that stuff up. But our eye only deals with visible light. It could be cloud and things like that, exposure, but I'm thinking it's a factor of the camera can take in a lot more data than our eye, because you got these cameras that can see in full spectrum or something like that, and our eyes can't. So there's like infrared cameras that see in the dark. And it's just infrared. I would see darkness, but since there's infrared light, the camera can pick up the infrared light. I'm thinking it's like that, yeah?
Scientists are saying there's oceans beneath our oceans, like many times bigger than our own ocean. So can you explain that?
Pseudoscience, real science. But there is.
No, it's not pseudo, this is real science.
There is, what was interesting is that our core is made of, the Earth's core is made out of iron. And iron is iron. Ding, ding, iron. But it's molten because it's under so much pressure and so much heat. If you dig down, it gets hotter. And that's molten. And it's moving around enough to make a magnetic field.
Where's that data coming from? There's
scientists.
Nobody that has gone down that far to find out if that's true.
No, they have
that's
drilled.
That's a hypothesis.
No, they do drill down. Super drill.
Stuff's going on.
The deeper you drill down, the temperature goes up.
I believe kilos.
Well, we'll get to your topic speeches. We need a whole speech at the ocean. Any other questions? So just go to nasa.gov. I'm sure you can get yourself a nice, cool screensaver of Aurora Borealis.
All right.
Oh, thank you.
All right, excellent. Let's give about 2 minutes on the